concentration. I'll be trying to explain something about concentration. What I want is for you to have the concept in the first place. So when we are talking about concentration, concentration is dependent on nothing else but the quantity of the solute being dissolved in a given solvent or solution. So when we are defining concentration, we define concentration as the amount of solute dissolved in a unit volume of the solution. So when we are calculating concentration, we calculate concentration by using the formula concentration equals number of moles over volume. But sometimes you're not going to be given number of moles, you'll be given mass. So it's very important as for you to convert that mass to moles if the concentration should be expressed in mole per decimeter cubic. But if the question is demanding you to leave your answer in grams per decimeter cubic, it means the formula for concentration will be concentration equals mass over volume, where this will be in grams and this will be in decimeter cubic. Therefore, we say the units for concentration, we have mole per decimeter cubic as standard units and the grams for per decimeter cubic as subunits. Very important. Now, I want to look at the factors that are going to affect the concentration of the solution is actually the number of moles and the volume itself. How is the concentration going to be affected by the number of moles or the mass as well as the volume? When we increase the volume in which we are dissolving a solute, it means the concentration will be reduced. And when we reduce the volume, the concentration is going to increase. Meaning the concentration is dependent on the volume and the number of moles as the quantity of substance. That is very, very important. What am I talking about here? We can do something. I have the source of distilled water here. I also have the source of the solute, and the concentration will be measured by this unit. And this is the tap as for me to remove the solution in a measuring cylinder. Now, without wasting time, I am going to change the solute to use. I am going to use cobalt 2 nitrate. So here I am going to have cobalt 2 nitrate as the solute. The solute here, cobalt 2 nitrate. I am going to add distilled water up to the mark of 0.5 liters. Okay, meaning 1/2, as you can see there. You need to remember that if we have 1 liter, it means we have 1 decimeter cubic of the solution. So allow me to add pardon me, allow me to add half a liter of 1 liter, which is 1.5 as 0.5. So I am going to add that. That is half a liter. Now I don't have a measuring cylinder. When you measure the concentration of this distilled water, when you pay attention here on the concentration part, you will find that the concentration there will be 0. As you can see, we are having 0.00, meaning water is neutral. There are no ions in water. Now, we are going to add copper 2 nitrate. I don't know the quantity I'm going to add because I have no way of measuring the mass. So, there we go. I am adding. As I'm adding, you can see that the concentration is changing. Now, the quantity I have added is giving me 1.564 mole per liter, which is mole per decimeter cubic. When I add some more, you will see that the concentration will be increasing, meaning the quantity of substance, as I'm increasing the quantity of substance I'm adding to water, even the concentration is changing. So meaning the number of moles is the factor that affects the concentration. Again, you will see that when I add more water, I am going to dilute this solution and the concentration is going to be decreased when I add more water. So let me add more water so that you can observe the concentration is decreasing. Up to 1 liter, the concentration has decreased to 1.105 mole per liter. So that's the reason why I was saying that number of moles and volume affects what? These two factors affects the concentration. When we increase the number of moles, we are going to increase the concentration. When we reduce the number of moles, we are going to reduce the concentration. That's the reason why it's very important theoretically for concentration to be calculated. And the formula which we use in theory, we use the same formula I gave you. Concentration equals number of moles over volume. That's the reason the units are mole per liter. That is very, very, very important. I have another important point to explain. I want you to look at this. I am going to remove this substance. Okay. I am again going to add half a liter of distilled water. That is half a liter. Yes, accurately 1/2 liters, which is 0.5. Again, there's something I want to explain before I end this video. I am going to add copper, or let me change the solute. Let me use potassium dichromate or nickel chloride, which is green in color. Okay, so I am going to add this substance. Pay attention if the volume of water is changing. The volume of water, even if I add this solute, the solute is not changing the volume of the solution. The question is, why is the volume of water or the volume of the solution remaining the same even though we add a solute. It's very important that you are able to explain that. When we are defining concentration, we are saying concentration is the amount of solute dissolved in a unit volume of the solution. So in this case, I have formed a solution. This is a solution. I have formed a solution. And this solution is nickel chloride solution. Okay? But this solution has been formed in 0.5 liters. That is the volume of the solvent, meaning the volume of the solvent, which was water initially, which was 0.5, equals the volume of the solution. So in the definition, if we want, we can change the position of where we have solution, we can put a solvent because the volume of the solvent equals the volume of the solution. Very important. And the volume of the solvent does not change even though we have dissolved a substance there. Why? Because every liquid, a liquid is going to have spaces in between particles. In a liquid, the particles are not very closely packed. There are some spaces between particles, and the same spaces is where now the dissolved solute will go and fit. That's the reason why the solute does not change the volume of the solvent, because there are spaces between particles in a solvent. And when those solute dissolve, the volume will remain just the same. As you can observe, I add 0.5 liters. Even after adding nickel chloride, the volume has remained the same. That is very important. And the concentration in this case, depending on the quantity I have added, the concentration is 1.338 mole per liter. Very important. I really wanted to explain this before I start doing calculations. Take note, very important. In as much as you are dissolving something, the number of moles of the substance you are dissolving and the volume of the solvent will affect the concentration of the solution. This is my introduction under concentration. Thank you so much as you wait for me to come and explain concentration and dilution. In fact, I'm going to connect this simple video to the notes I am going to teach you, where I'll be explaining them. Thank you so much. Take care. I promised to explain concentration and dilution in connection with my video. So now, let me explain some important points so that I can actually prove my explanation in my practical. We define concentration as the amount of solute dissolved in a unit volume of a solution. This is very simple because I showed you that the solution and the solvent the volume is just the same. So we can say in a unit volume of the solvent or solution, because the solute does not affect the volume of the solution or solvent. The volume will just remain the same. Again, I talked about the units. I said the units can be grams per decimeter cubic or more per decimeter cubic, reason being that the quantity can be given to you in form of mass or in form of moles. Therefore, the units for concentration, I said, it's grams per decimeter cubic or more per decimeter cubic. But the standard units are more per decimeter cubic. If the mass is given and the volume of the solution or solvent is given, this is the formula. Mass of the solute over volume of the solute. If in moles, we are going to say number of moles of solute over volume of the solution. Remember, every time under concentration, the volume should be in decimeter cubic. If at all we dissolve 1 mole of the substance in 1 decimeter cubic or 1 liter, what is formed is a molar solution, and the concentration is known as molarity. This is what the point is trying to explain. The concentration expressed in mole per decimeter cubic is molarity, and it's represented by a capital letter M, where we say molarity equals number of moles over volume. Take note, molarity same as mole per decimeter cubic. Number of moles in moles, volume always in decimeter cubic under concentration. We have an example. I am going to do this example very fast. A solution of glucose containing 0.45 grams of glucose. This is dissolved in 0.07 decimeter cubic of the solution. This solution should not confuse you. It means solvent, same as solvent. We are calling it a solution because we have dissolved the glucose there, so it has formed a solution, and the volume will remain that it will remain the same. Calculate the concentration of glucose solution in grams per decimeter cubic. They have given you their desired what units, so meaning you give them what they want. We are going to calculate. First of all, we are going to come up with data. Very important. They have given us the mass of glucose to be 0.45 grams, and they have given us the volume to be 0.075 decimeter cubic, and the concentration is what we are looking for, X. What are we going to do? Okay, fine, we are going to say concentration. Concentration is affected by mass or number of moles as well as volume. So the volume is that, and the concentration is not given, and the mass is given. So mass over volume, where we are going to say 0.45 grams over 0.075 decimeter cubic, where the answer is going to be 6.0 grams per decimeter cubic. As simple as that. Very important. We can look at question number 2. We see how the question is going to be. The question is saying, find the concentration in mole per decimeter cubic of a solution of sodium hydroxide if it contains 3.5 grams of sodium hydroxide in 100 of the solution. The solution, this volume is giving us the solution of sodium hydroxide, meaning we want the concentration. Remember, this mass and the volume 100 will determine the concentration of sodium hydroxide. Whiteboard data. We have mass, which is 3.5 grams, comma. We also have the volume, 100 centimeter cubic, comma. The concentration is not given, X. Now, this concentration should be in mole per decimeter cubic, meaning it's very important as for us to convert this volume to decimeter cubic by dividing this by 1000, which will be equivalent to 0.1 decimeter cubic. We have converted that, and then this mass should be converted to moles because the units is mole per decimeter cubic and not mass per decimeter cubic. So we are going to say mass being converted to moles, moles equals mass given over molar mass. So number of moles 3.5 grams over the molar mass of sodium hydroxide. Sodium hydroxide, when you go back to molar mass, you find that it will be 40 grams per mole. If you have forgotten how to calculate the molar mass, you can go and watch the video so that you can be reminded on how we are doing it. And the final answer for the number of moles of sodium hydroxide will be 0.087 moles. Very important, of sodium hydroxide. Now you have the number of moles and then you have the volume. These two factors will affect the concentration. So we are going to say, okay, fine. Therefore, in this case, concentration will be number of moles over volume, where we'll say the volume, the concentration is 0.087 moles over 0.1 decimeter cubic. Therefore, concentration will be equal to 0.875 mole per decimeter cubic. Wonderful. This is how far you are supposed to go. I have given you a concept. Nothing is difficult here. Remember another important point. Another important point here is that dissolving a substance in a given solvent is not a chemical reaction. You are just dissolving that substance, meaning the number of moles will remain the same. What will be changing is just the volume and the concentration. And the concentration itself will depend on the number of moles and the volume. So the factors that affects the concentration, we have number one, we have number of moles in that solution and the volume of the solution or the volume of the solvent, which is actually equivalent. If we have 2 liters as a solvent, even the volume of the solution will be 2 liters. Don't forget that, my dear learners. Multiple choice questions, you can be examined like that. Since the volume of the solvent is 2 liters, what will be the volume when 20 grams is dissolved?